Let's now consider the sine function. Here I have a nice unit circle. Notice that in black I've drawn the angle. The angle is 0, the angle is pi over 2, the angle is pi, the angle is 3 pi over 2, the angle is 2 pi as I come all the way around the circle. And in green, I've drawn in the xy point. If this is a unit circle, we know that the radius is 1. So when the angle is 0, or 2 pi by the way, we're at 1, 0. That's cosine comma sine on a unit circle. And when the angle is pi over 2, we're at 0, 1. That's cosine comma sine at pi over 2. And at pi, we're at negative 1, 0, cosine comma sine. At 3 pi over 2, we're at 0, negative 1, cosine comma sine. And then we go back to 2 pi. All right. So what I'm going to do now is I'm going to take my scissors and I'm going to cut this unit circle right there, right at 0 radians or 0 degrees. And then I'm going to unroll the unit circle. So 0, pi over 2, pi, 3 pi over 2, 2 pi. I've unrolled it in a straight line. So we are considering the function y equals sine of the angle. And here the angle is theta. So let's chart what happens. When the angle is 0, our sine, which is the y, is 0. So I have this point right here, right on my axis. When the angle opens up, here's our angle, it opens up to pi over 2. At pi over 2, sine of pi over 2, we know is 1. So when the angle is pi over 2, our input is pi over 2, our output, the function value, is 1. When the angle goes to pi, our y, or our sine value, is 0. When the angle opens all the way up to 3 pi over 2, our sine of 3 pi over 2 is negative 1. I'm following the y, because we know on a unit circle, sine of theta is the y over 1, but we just say y. And at 2 pi, our sine of 2 pi goes back to 0. So if I draw a smooth graph through these, this is the classic parent function of the sine curve. It has this point, 0, 0, and then pi over 2 comma 1, and then pi comma 0. Down here we have 3 pi over 2 comma negative 1, and at 2 pi we have 2 pi comma 0 again. Now this graph that I'm going to say goes 0, maximum of 1, 0, then a minimum of negative 1, and then 0. So the 5-point pattern for this is 0 max, 0 min, 0. 0 max, 0 min, 0. That is our pattern, 5-point pattern for the sine curve. Notice that's a mountain and a valley. We say that the period, I'm drawing this, it looks like, well, it's a lambda. The period is 2 pi. That's one full cycle. Think if we were building the school, we'd need a lot of bricks. And each of these is 1 brick. Why do I say it's only 1 brick? Well, this is one repeatable unit. We call it 1 period, or 1 cycle, or 1 wavelength. And it goes from 0 to 2 pi. It's going to continue on and on and on in both directions. So I just looked at the angles from 0 to 2 pi. If I went from 0 to 2 pi, I'd have 0 max, 0 min, 0, 0 max, 0 min, 0. It would keep on going in both directions. Or if I went from negative 2 pi to positive 2 pi, I'd have 0 max, 0 min, 0, 0 max, 0 min, 0. So each one of these 0 max, 0 min, 0 is a repeatable unit for the sine function. Now you can really see it's a sine function because when we graph it, we know from our time in algebra that functions pass the vertical line test. Any vertical line drawn anywhere on our graph will intersect our graph in one and only one spot.